This is Tim Doyle with Festo US coming at you from the Chicago office. Today I'm going to show you how to use our new SBS vision sensor and connect it with Rockwell Studio 5000. First off, we're going to download the software that we'll need for this. And to find that, we're going to go into Festo US's website and we're going to go up to Products in the upper left-hand corner. Click that, and then we're going to scroll down and find Machine Vision Systems. And we're going to click that as well. This page will give you more information about our SBS vision sensors, and it'll also give you some documentation as well as the software that we need for this. I already have this installed, but this is where you can find it. Here I have the vision sensor software up and running. I'm also going to show you that with that vision sensor we also have instruction manuals with that as well. So we're going to go find our Festo software, and we're going to scroll down until we find our SBS vision software, which right here we found, and then here's our user manuals for that. I'm going to open up the communications manual, and I already have a page open to that I want for this, which is page 75. We'll come back to this a little bit later. Here we're going to input our IP address. Fresh out of the box, your IP address for your SBS sensor will be 192.168.100.100. Here I have 4.100. That's because I've been playing around with my SBS software and I have changed my IP address. So if you're coming out pulling SBS vision sensor directly out of the box, it should be .100.100. And then we're going to add that. I already have this, and I'm going to double click. And here I have my vision sensor up. I already have a job defaulted on this because I've been playing around with this, but I'm going to show you how to create a job and how to have outputs so you can have your Rockwell software look at this. Here we can see that nothing's really in focus, so we're just going to use the auto shutter speed real quick to get the brightness right, and then we're going to use an autofocus for it as well. But right now our autofocus is looking at this purple area, which isn't necessarily the part that we want to look at. So I'm going to shift it down over here, and I'm actually going to change out the part that I want to use for this. And then I'm going to click the shutter speed again, and there we see our part. And then I'm also going to put this back where I want the focus to be. Hit that again, and then I'm going to auto focus for that, and this should come in a little bit clearer. All right. From there, we're also going to change our trigger mode from free run to trigger. Alignment we don't necessarily need to worry about right now, and then detector, we're going to, for sense of purposes, we're going to create a new detector just to show you, but we're going to click new, and for my detector I just want to do this fairly quickly so we can get to the how to connect this to Studio 5000. I selected contour, and then in contour we can select a different color scale. I'm using a grayscale for this. And then I've also, this green area is the contour that I selected. I created a threshold for 72 to 100, so that minimizes the amount of error that you're going to find. I also changed the angle range to 180, negative 180 to positive 180, so full 360, it should be able to find this contour. We can also edit this contour, like we can see this little green spot that we don't necessarily want. I'm going to delete that, and now we're just looking at that arc. So then here we're going to have outputs. We're going to go down here and see Ethernet IP. We're going to hit this check mark, and we're going to make sure that this is a 1 here. And then we're going to go into Telegram, and we are going to need to create a few detectors. First one we're going to need is the overall result. This helps translate the information to the Rockwell software, and then from there we can put our different detectors. So for here I have a score, I have a position X, a position Y, a counter pass, and a counter fail. The next thing we need to take into consideration is the bit depth. This is the size of the data package that is going to go over to the Rockwell software, and we'll need that for setting up our SBS device. We need to take note that our bit depth is 32 bits is the largest, so we'll keep note of that. And then from here, we should be okay. I'm going to exit out of the screen. And then I'm going to open up our Rockwell Studio 5000. And I already have a program sort of pre-written in here, but we'll get to that later. Just did that for a sense of saving a little bit of time. First off, we're going to go to Ethernet here, and then we're going to import a new module. Here, we're going to type in Ethernet, and then we're going to put dash. This is probably the easiest way to find the Ethernet, the generic Ethernet module, and then we're going to create that. I'm just going to call this SBS, and then I'm going to change this from dint to cint, and then I'm going to input our IP address. So 192.168 for you.100.100 for me.4.100. And then we're going to find the assembly instance in the documentation that we pulled up earlier. This is where we're at in the documentation, but we're going to scroll down to here, and we're going to find the 32-bit. With these documents we can use, I'm going to play around with this a little bit later, so I'm actually going to go a little bit higher than 32, so I'm going to go up to the 64-bit, but you are more than welcome just to use the 32-bit. So these are the inputs that I'm going to put into that screen, which are 105, tab, 72, tab, tab 3, tab 1, tab 0. And this should be all connected. So we'll click OK there. We'll exit it. We'll click OK here. And then from here, we're going to start creating some local tags. And then you can take a quick look at this and the quick logic that we have to see what we're doing here. So here, I'm going to create a tag, X, trigger, button, and then we're going to use a bool. We'll create that. Here, we'll do tag X ready, and we're going to have this an alias for a different. So we'll go SBS input, and then we'll go data 0 dash 0. All right, great. Next one, we will go to create that. ONS trigger. This is also going to be a bool, so we'll just create this. Oh, that was the wrong one. Edit. This is X operation mode, and this is also an alias for input data 5, 6. Okay, now this one is ONS bool. ONS trigger. And then our output, new tag, X trigger, and this will also be an alias. 0, 2. And these input outputs can be found in the user manual that we just dug up. And then we'll create that. And we'll go on to the next one, which will just be the X trigger button. New tag for the one after that, which will be X trigger acknowledge. And that will be input for the output. 0, 2. Create that. And then this is just the X trigger from before. All right, source A will be an input point. And then we'll go to input, SBS data, and then we're just going to select 8. Source B. We're going to create a new tag, call that overall, and we're going to change this to Sint. And create that. So our bits 0 through 8 are all delegated to communication, and then our inputs coming into the software are going to be all the bits after that. So when we are looking at the source for our sensors, we're going to be starting with bit number 9. And we're going to see that right here. Also, the sources that we're going to be using here are going to come in the same order that they're set up in how we set them up in our device. As we see in the communication. So if we go to output and we look at our telegram, the first one that's going to pop up is score, second one's going to be position X, the third one's going to be position Y, then counter, and then fail. Go back to that. And I'm going to set that up with here, and we're going to go starting with input data number 9. And then each input is about 4 bits large. So our length is going to be 4 for each of these. And our destination will be a new tag. And we'll go score temp. I'll create that. And then here we'll go score. Temp. Order, reverse, destination, score. And then we'll create a new tag. Create. And then here, since we have a bit depth of 4, we're going to go from 9 to 13. Destination, position, X, temp, length 4, and then we'll create that. Position X temp, reverse, destination, position X, and then we'll create that. Next one, 13, 17. Destination, position Y tap. Four. And then we'll create that new. And then reverse. And then position Y. And we'll create that tag. Source 17, then 21. Destination, we'll go to pass temp. Size 4, enter, create new. And then we'll create that as well. And our final one will be the fail, which 21, now going to 25. Destination, fail, temp, size 4, create U, and then we'll go to fail temp, order mode reverse, and then destination fail. So we have our system created. We have our connection to our SBS module. So from here, we're just going to create a path to our PLC and download this to our PLC and run it. So communications, who active. Takes a moment. We're going to set our project path to our PLC, and we're going to go online. So first thing we should check is to see if our Ethernet module is running. So click that, and we have a status of running. So our numbers are good here, and we're going to click OK for that. We are in remote run mode. So then from here, I currently have my software open. So from here, I'm going to have to click Start Sensor. If you didn't have this window open, you just you should be able to go online with your sensor without having the software running. And then from here, I'm going to hit that trigger button, and we should be able to get some data. And yes, we have some data. We have a score of 99.7%. Our position X, our position Y. We have a pass, which makes sense. And then we also captured a new image of our piece. And we also can see the counter here as well. And we can also see the score. We can see the position in pixels. And yeah, so I'm going to move the part around and take more pictures and see what kind of results we're going to get. I'm going to show off my hardware. In the lower right hand corner, you can see my current setup. I have a brass fitting, I have my PLC, and I have the SBS sensor. I'm going to move the brass fitting a little bit, and then I'm going to trigger our device again. And from there, we have a second pass, we have a new score, we have a new X position, and then from here I'm going to try to get a fail, so I'm going to completely switch out the piece. For a new piece that does not look like our previous piece. And I'm going to trigger again. And we have our first fail as expected. We also have a new image. Clearly see that is not the piece that we've been working with. So our communication has been set up with our SBS sensor and Rockwell Studio 5000, and I hope this helps you in the future. Thank you. Have a good day.